Hi everyone, today I am going to present a study looking at individual variation in optimal encoding strategy in visual working memory. Imagine that you're shopping for groceries at a market and that you're trying to remember the prices of all these items since you want to compare with the prices at another store. So some of you might be able to remember all of these items, but it's also likely that you can only remember some of the prices listed here. So there are large individual differences in working memory. An intuitive reason for why this is the case is that there are large differences in our store's capacity. However, previous work has shown that it's not just about how much we can store, but also about people's selection abilities. For example, you might decide that you only need to get tomatoes from the store. So some people might just be better at selectively remembering these items and ignoring everything else. So work has shown that working memory might be related to large differences in our attentional control abilities. However, there might be strategic differences in how we try to remember items and what we choose to remember. But it's actually unclear how strategy use might vary across individuals. Here we ask to what extent we might use optimal encoding strategy in working memory. So some people might actually avoid using optimal strategies because there are strong cognitive demands of being optimal. And we also want to further understand whether strategy use is related to individual differences in our ability. On one hand, it is possible that working memory capacity can predict optimal strategy use. So people with high working memory capacity might be more strategically selective in what they remember. On the other hand, work has also suggested that working memory capacity does not predict optimal strategy use in the context of visual search. Here we ask participants to do a flicker change detection task. So their job was to localize a change that occurs between these two displays, so whether a bar is rotated differently. Instead of showing these displays just once, we repeat these displays until participants report a change. Importantly, on every trial, there are always two targets. One red bar and one blue bar will change its orientation by 90 degrees in the second display, and people only need to report one of these targets. There is always one color that contains fewer items in the display, and the other color will contain twice as many items. And this small subset color will change between red and blue on a trial-by-trial basis. So here people are given the choice to report either the red target or to report the blue target. But the optimal strategy is actually to find the small subset target. So if your goal is to find this target, you can just remember the 3 items within the small color subset and ignore the other color. So here we refer to this target as the optimal target and the target within the large subset, the non-optimal target. So in this task, aside from looking at general measures of performance such as accuracy and response time, we could also look at optimality rate, so how often people actually report the optimal target. And this is our main measure of strategy here. Here, I'm going to show you what an example trial looks like. Just remember that the optimal strategy here is to try and remember the small subset and to find the target in that color. So in general, using this optimal strategy should be faster than trying to find the target in the large color subset or to disregard color completely and to pick a random set of items to remember. So in this task, we never tell participants that this is the optimal strategy, but participants do know that there are always 2 targets and it's completely up to them to report either the blue or the red target. Here, I'm just showing you how often people actually report the optimal target, the non-optimal target, and a non-target. So as expected, people are mostly very accurate on this task since they are given the chance to repeat displays multiple times. But interestingly, people don't always choose the optimal target. And we're curious about the individual differences in people's target choice here. So this is a histogram of people's optimality rate. And there are some participants who almost always report the optimal target, but there are also a lot of participants who only report this target on half the trials. So this suggests that strategy use is actually frequently suboptimal and that there are large differences in what people choose to remember. So one main assumption of our task is that finding the target within the small color subset is the optimal strategy. So to verify this assumption, we tested whether optimal strategy use is related to response time on this task. If this is indeed the optimal strategy, then it should be faster for people to look for the optimal target. And this is exactly what we found here. So in generally, choosing the optimal target is faster. So we want to further understand these individual differences in optimal strategy to see if they are related to people's abilities. So we also tested whether working memory capacity can predict people's optimal strategy. So here we independently measured working memory capacity in a one-shot color change detection task. And our results show that optimal strategy use is not related to working memory capacity. So these findings suggest that individual differences in optimal strategy isn't simply explained by differences in working memory ability. In experiment 2, we want to follow up more on these strategic differences across individuals to see if they are actually trait-like. So there are two possible ways that a person's trait could play a role here. On one hand, it is possible that there are stable individual differences in strategy use over time. So people might consistently use the same strategies across multiple test sessions. On the other hand, strategy use might involve some kind of learning mechanism. So the pattern of results that we see here might just reflect individual differences in learning rate. So people might differ in how quickly they learn this optimal strategy. To test this, we have participants do the task on 2 sessions on 2 separate days. So here we plot session 2 optimality rate on the y-axis against session 1 optimality rate on the x-axis. Here, the reference line is the point at which people show the exact same optimality rate across test sessions. So if strategy is actually stable within the same individual, then the individual data points should fall close to this line. So we did see that some participants are consistently reporting the optimal target or consistently far from optimal in both sessions. But surprisingly, there are a lot of participants who became a lot more optimal in session 2. This finding is actually quite surprising, and in contrast to work showing that strategy use is stable and consistent within the same individuals. And this also raises the possibility that there might be differences in how quickly people figured out the optimal strategy. To look into this more, we also conducted some exploratory analysis to examine how optimality rate changes from block to block. Here, I'm just showing you the group results for all participants, but I am most interested in the learning process for each individual. So whether these changes over time are due to a gradual improvement, like a steady rise in optimality rate, or is it due to a sudden discovery of the optimal strategy? So there are indeed some participants who are consistently suboptimal across sessions or across all blocks. And there are also some participants who are consistently reporting the optimal target in all blocks. But interestingly, there are a lot of participants who show a sharp increase in optimality rate from one block to the next, and then they seem to completely switch this optimal strategy. So there is actually variability in when this sharp increase occurs. So some people seem to learn this optimal strategy very quickly within the first few blocks, but others seem to learn this later on. So this pattern, like the sharp increase in optimality, might just indicate that the changes over time we see in some participants are due to the discovery of the optimal strategy rather than gradual improvement of strategy use. To sum up here, we investigated individual differences in strategy use, and we found that using the optimal strategy of remembering the small subset and finding the target in that color actually leads to better, faster performance. But interestingly, individuals do not always use the optimal encoding strategy. And we further showed that strategy optimality is not simply explained by differences in people's working memory ability. And finally, we also looked at how people use strategies over time. And our results suggest that individual differences in strategy use might be related to the learning and discovery of the optimal strategy. In the future, we would like to explore this even more by examining the role of strategy instructions. And finally, I would like to thank my lab and thank you all for your attention.